Okay.
All right.
So when you're taking the test, you're not going to know the topic. You know, you won't have a specific topic. You've got to take each question as they come and try and, you know, figure out, well, what's the process? What am I going for on this particular question? So this one says the table below contains the results of a biology experiment, and it gives you the table with the weeks and number of blooms. Assuming the pattern shown in the table continues, what is the value of B? So what we want, whatever's going on from number to number, to be a similar pattern. So when you think of patterns, what do you usually check for?
Like, is it going up or down, and how many?
Okay, is it going up or down, and by how many? So it's definitely going up, and let's figure out by how many. So from 3 to 9, how much is that?
Times 3, so is that 6?
Multiplied by 3. Well, there's 2 options. Times 3, that would work, or add 6. Might be the times 3, might be the add 6. When we don't really know the topic, could be either. We're going to check on the next one. From 9 to 27, does one of those work? Is multiplying by 3 going to work, or adding by 6 to get you
multiplying 3?
Multiplying by 3. So that's how you know it's a pattern, is you said, well, I had 2 options, only one of them worked. That's the pattern I follow. I'm timesing by 3 every time. So to find the next one, we multiply by 3 again.
No.
So you do want to go to probably your calculator, because that's a big one to multiply. So I did have it confirmed by the testing coordinator that it is going to be this Desmos calculator. But you do have to click it open yourself. Like, I don't think it's going to automatically pop up the calculator. So even if you're given a separate one, there should be this built-in one as well, where you have to click on the calculator to open it, use it, and then you probably close it in between questions.
243. B.
Good. D. Good. Okay. So a box and whisker plot. The box and whisker plot below describes the weight of samples of 100 chickens. I think we did a problem like this last week. I don't remember if it was the exact same one, but we did talk about box and whisker plots and how there's a lot of information from this. So we have to kind of have memorized what each of those means. So what statement can be made? Let's check each statement one at a time. What did range mean?
Range mean altogether. Right?
Altogether, kind of, it meant the top number, so the biggest number, minus the smallest number.
Right.
So kind of a similar concept, but we do need to know for sure, you know, this is the exact top number minus smallest number. So what is the top number from that graph, or the biggest number on that graph?
And 2.5.
Good. They didn't mark it in between, but each tick mark is going up by 0.1. You kind of have to figure that out yourself from the things they do have labeled. And what's the smallest?
0.4.
0.4. And then we subtract those 2 numbers. So that gives us 2. So then we have to decide, is this statement correct?
No, because it's in is, it don't say about.
Yep, it says it is, which is exactly. It should be exactly 3, but it's 2. So if that one doesn't work, we move on to the next one, the median. Do you remember what median meant?
The median is the middle number, right?
The middle, specifically the middle line of the box. This line here is the median.
So is that what, like 1.8 or something? No.
1.9.
1.9.
We have 1.6, 1.7, 1.8, and that would be 1.9. So is the median less than 2 pounds?
Yes.
Yep. So this is our correct one. So on these kinds of problems, we do have a lot of definitions, and these will not be, you have that reference sheet that has some of the formulas, but it's not going to have these definitions. You need those kinds of definitions memorized. Which equation is equivalent to this expression? So this somehow matches one of these. So for this, we have to actually go through and try to solve this equation, even though it doesn't say to solve, it asks which one is the same. Somewhere in our solving process, it should end up looking like one of these. So when you solve an equation, what do we do about the parentheses? There's a specific step to take when you have parentheses as part of your equation.
You do them first.
What do we do with them?
We solve them, right?
If we had no variables, you would solve what's inside, but the variables make it harder. You're thinking of like if we had 3 with 2 minus 5, no variable involved at all.
Yeah, right.
With the variable, I can't actually do a 2x minus a 5. They're not compatible.
Right.
So do you remember something called distribution?
No.
Okay. So distribution is where you take the outside number, the 3, and multiply it in to both things inside. Parentheses tell you to multiply. If we had a problem like you were thinking where you do 2 minus 5 and get this negative 3, once you do what's inside, you would do 3 times 3. You multiply next. This one we have to start with the multiplication and do the 3 times 2x and then the 3 times negative 5. So what do we get when we do the 3 times 2x?
Well, we get 6x.
Very good. And then the 3 times negative 5.
Three times. Well, would it be 15?
Negative 15. When you
Negative 15.
Yep, when you have a positive times a negative, 3 times.
Is it always negative?
Yep, comes out negative. And that's different if you have addition. That's different. 3 plus negative 5 is different than 3 times. So that's why the rules can get kind of tricky because it's different for addition versus multiplication. So then we have to do the same thing on the other side. The other side also has parentheses. So we have to do the front number times the x, and then the front number again times the 3. So what do we get when we multiply the 4 times the x?
Will we get 4x?
Good. Nope, that's exactly correct. And then we do the 4 times the 3. And this time it's positive times positive, so definitely still positive.
So it'd be 12.
Good.
Or,
Okay. So we still don't look quite like any of this stuff over here. So we still have more steps to do. When you're working with an equation, there's the two different sides, the left side and the right side. And we just had April join. Thanks for joining us.
You're welcome.
Yep. We're working on this problem here. We're just going through a test and going through different random topics today instead of one specific topic. So we've been working on how to solve an equation like this. It doesn't say the word solve, but we've got to make it look like one of the answers, so we do have to solve. So first we distributed, we multiplied stuff in. When you have parentheses, you have to multiply into the parentheses. And now we're here with the 6x minus 15 equals 4x plus 12. And now we have to do opposites. We want to take all these terms and move them across the equal sign to the other side. So like we want to move this 4x over to be with the 6x. But when you move it, you have to do the opposite. So right now the 4 is positive, and what's going to be the opposite of that?
Negative.
Negative.
Negative. We minus the 4x. And the reason we picked that is because 4 minus 4, that's 0. If it's 0, this whole thing just goes away. But what you do to one side, you have to do to the other. So what do we get when we do the 6x minus the 4x?
2x.
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 Negative. Yeah, 2x. Okay.
Positive this time. So
Right.
with addition and subtraction, the bigger number, it determines whether it's positive or negative. So now we're looking closer. Now we're either A or B because C had 10x instead of 2x. So now we want to do the process again, but we want to get the negative 15 and move it to be with the 12. So now what's our opposite?
Positive.
Positive. We're going to plus the 15. Now, if you don't like writing it on both sides, you can just cross it out. We chose to do the opposite, and it gets rid of it. And then we just combine together. What do we get when we do the 12 plus 15?
7.
27.
27.
Good. Yep. So normally you would have one more step. Normally you would, if you were asked to solve, you would then divide by 2. This time, since we only want the 2 to go away, the x is going to stay. The opposite is to divide. So normally you would do that, and this time you get a decimal. That would be 13.5. But since we were just trying to get it to look like one of the answers, what does the 2x equal 27? Is that A or B?
A. Me, B.
B. They did kind of try and trick you there. Yep, because it's positive. So be careful, because they do try and trick you with stuff like that. They make it very similar when it's that small difference changes what the answer is.
Was that the first problem you did?
No, we did 2 others. We talked about this pattern and talked about how your pattern can either be addition or it could be multiplication. Usually it's one of those 2. And when we checked it, the one that worked every time was the multiply. Your pattern just has to work every single time. And then we talked about these box and whisker plots. There's a lot of information on box and whisker plots. We actually talked a lot about box and whisker plots last week. So if you don't know, where the median is or what range means, you may want to watch the video from last week, because this one there's a ton of information on these kind of graphs.
Okay.
So this one looks like it's a geometry one. I'm going to zoom out a little bit so we can see more of the question. Darius and his father are constructing a set of bunk beds as shown in the diagram below. What is the measure of angle X? So I'm going to zoom into the picture a little bit more. Some of these answers we can eliminate. If you look at angle X, it's definitely bigger. Do you know what a big angle is called? There's a certain math word for a big angle.
Is it obtuse?
Good, obtuse.
Obtuse.
Yeah.
Obtuse means it's bigger than 90. But smaller than 180.
Hmm.
So since this is obtuse, we can actually eliminate some answers. Which ones don't fit that description?
Okay, bigger than
A.
9.
A does
B.
not.
390 don't either.
A and B don't work. It could be C or D.
C is, yeah, it's smaller than 180. Okay.
Yeah. So C might work and
I
D
think
might
it's D.
work. Okay. So how do we know for sure? In a shape, there's a specific formula, but they're not going to have this formula on the reference sheet. So we're going to remember it a different way, because one thing that most people remember, because it's used a lot, is how many degrees are in a triangle. Do you have
90.
not 90, how many?
180.
180.
Yeah.
This kind of looks like a 90-degree angle that I drew here, but if you add up all the angles inside, if you look at this one and this one and this one, all together that's 180. So if you split this shape into a whole bunch of triangles, all the triangles you possibly can, how many triangles does this shape make?
3.
3. And you can't cross over. Like I could draw a line from here to here, but then I crossed over. So you can't have any crossovers. So if there's 3 of them, all 3 of them are 180. So that means total, and I'm going to pull out the calculator. We're going to add 180 together 3 times since there's 3 of them. So 540. In this entire shape, this is actually a pentagon because there's 5 sides. Yep. So this is a pentagon, even though it looks different than pentagons we're used to. In the entire shape, we have 540 degrees, and they told us every other angle. What are these angles where they just put the mark? How many degrees does this kind of right angle mark tell you? I don't think did either of you say the answer? How many degrees are in a right angle in this?
90.
Oh, 90.
90, okay. So all these corners are 90 degrees. And then they told us this corner, 120. So if they're all supposed to add up to 540, if we just take all of these away, it leaves us with the last angle we don't know yet. And we do this process a lot in triangles. They'll give us 2 and we find the third. This time we're just doing it with more angles because the shape is bigger. So 540 minus the 120, minus the 90, minus the 90, minus the 90.
150.
So 150 is our final answer.
So C.
So
I was kind of figuring that anyways because it looked like a bigger half circle.
and that's another way to look at it. If you look at the 120 looks smaller than this circle. So this problem you probably could have solved just by saying, well, I know this is less than 180, so that gets rid of A and B, and I'm pretty sure it's bigger than the 120, so it has to be C.
Mm-hmm.
And that's a great way to think about it, is to kind of use a little bit of logic.
Yep.
So this is one of those free response where you're going to have to type in your answer. Again, I'm not exactly sure how they're going to do it, but I do know there are some of these questions, even with the it being on the computer now. Okay. So 3 different opinion polls showed different results for the proportion of voters expected to vote for candidate A in an election for mayor. And then it gives you information about each poll. 9 out of every 20 voters are expected to vote for candidate A. The percentage of voters expected to vote for candidate A is 52%. There are 135,000 people expected to vote, and of these, 55,000 are expected to vote for candidate A. So then the important part, the part that tells you, what do I have to do with this question? In your answer document, determine which of these polls shows the greatest favorable result for candidate A. So greatest favorable result. Show your work or provide an explanation for your answer. So when stuff is all presented in different formats, then the best way to compare them is to get them all into percents. If you want to compare items, make percents. So poll 2 we're actually okay with. Poll 2 is already a percent. Poll 1, if it's 9 out of every 20, how do I make that into a percentage?
You have to times it.
Timesing is when it's already a percentage. If they said,
Oh, okay, so then it'd be dividing it, wouldn't it?
mm-hmm. Yeah, if they said like find 9%, then you would end up multiplying, but when you're trying to find the percentage, we do
52
division
over 100.
That I think you're looking at poll 2. We're looking at poll 1.
Oh, okay. I'm sorry.
That's fine. So 9 out of every 20, we're doing 9 divided by 20. And for that, you have to use a calculator. There's no way to, well, there's very long, intense.
It'd be a long division.
Yeah. So 0.45, what is that as a percentage?
45%.
45%.
Yep. You could, if you wanted to actually see it, you could times by 100 because all percents are out of 100. Or most of the time we can tell, 0.45, that's 45%. So poll 1 is 45%. And I would show that work. I would say poll 1, sorry, wrong. Poll 1, 9 divided by 20 equals 0.45, which is 45%. I think showing that process right there is enough. Poll 2, it's already a percent. We don't have to do anything, but I would still write out poll 2 is 52%.
Yep.
So then poll 3, we have to figure out our percentage again. How are we going to figure out the percentage if there are 130,000 people and 55,000 are going to vote for candidate A?
Are we going to divide again?
We're going to divide. They switch the order of the numbers. Always do the smaller one divided by the bigger. So even though they wrote 130,000 first, we're going to do 55,000 divided by 130,000. And I'm typing that into my keyboard. You could also bring up this thing at the bottom and actually click on the stuff. So what percentage is this? The decimal's much bigger. What's the actual percent?
Is it like
42.
Yep. So 42, what do you think, Naisha?
42 because the 3 don't move it up, so.
Yep, the 3 is not going to round it up. You could just do 42%. You could even do 42.3%. I think both would be acceptable. If it were like 42.6 though, and you just did 42, you're right, you would want to round that up. If it was 42.6, write 43. Oh, but I would write the whole process. Don't just write the percent. I would write that you did 55,000 divided by 130. And that's approximately, up here I did equals because it was exact. This time it's approximately 0.42, which is 42%. So now the actual answer to the question, which poll shows the greatest favorable result? Which one's the best?
It'd be the poll 2.
Mm-hmm. And I would actually, write a sentence.
Well, put I feel that poll 2 would be the greatest favorable result for candidate A.
And that would be a great sentence. Favorable candidates for candidate A. They're not going to care about your spelling, so if you mess up spelling, that's fine.
I'm good with that on some things.
Yeah. I might add one more. It says show your work. Probably we're good. You could also add on at the end because it has the highest percent. Because poll 2 has the highest percent. Just to be a little more specific. I don't think you'd lose the point, especially if you show all the work, but it never hurts to show, hey, I know exactly what's going on here. Okay. So a set of data contains 10 negative numbers. Oh, I think we did talk about this one last week as well, because I did specifically just statistics. So do you guys want to see this one again or move on to a different one?
I want to see it again. I didn't get to see it. I was trick-or-treating last week.
Okay. So a set of data contains 10 negative numbers. They don't tell you the 10 negative numbers. It could be any 10, it could be negative 1 million, negative 5, like it can be any 10 negative numbers and 4 positive numbers. Which of these statements must be true? So not could be true, because a lot of the times they could all be true, but it must be true no matter what. So the
B.
mean,
I said B.
good. So we need to know what's the difference between mean, median, and mode, and range. So mean is the average, adding them all together and dividing by however many there are. Median is the middle. Mode is the one most often, and range is just the highest number minus the smallest number. So the only one, as Naisha said, that must be true all the time is the median. If you have 10 negative numbers in a row, even if I changed them, negative 8, negative 7, negative 6, negative 4, negative 3, I think that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 4 positive, 1, 2, 3, 4. The middle of this is somewhere around here. I'm not going to do it exactly because it doesn't matter that much. So no matter what 10 negative numbers I did, and no matter what 4 positive numbers, the middle is never going to change. Where the other ones, they're all affected by, well, are these big negatives or small negatives? Are they use, do I have 4 positive numbers that are the same? Then that's the mode. So median is the only one that must be true. And a problem like that, if you're in the middle of the test and you're just like, I'm not sure at all, you can always skip questions and then come back later. And if you just feel like I'm never going to get this one, I'm going to just make a guess. Any questions you guess on, just pick one. I'm going to always pick B for my questions that I guess on. Because if you pick the same letter, it's going to be better for you overall. As long as you're not guessing on too many.
Yeah, because then they're going to know you're guessing.
Yep. Okay, so Travis went on a long trip. The graph below represents the relationship between distance and time. And they show time is the bottom and distance is the vertical. And I'm going to have to zoom out again because too much of this question. During what interval was Travis's average rate of travel the fastest?
Looks like 11 to 16. Well, the 16.
So 11 to 16 is that piece. So what do you think is going to represent the fastest when you're looking at a graph?
Um,
Do you think it'll be the longest piece?
It'd be the lowest, right? I don't know.
No, that's the hours. The distances would be, if you look at the distance, that should tell you. Probably the one that's the highest, 11 to 16.
So the highest, let's look at our distance. We went from, let me get back to that same color. We went from 450 up to 550. So that's 100 miles. And how long did it take? If it was from 11 to 16, how many hours did it take us?
About
16 hours, right?
15 hours. Well, so 16 hours is the entire time. If we're just looking at that last piece, the time from 11 to 16.
So it'd be 1, 2, 3, 4, 6 hours.
1, 2, 3, 4, 5 hours.
Okay.
Well, you got to go 11 to 12, which is 1 hour. 12 to 13 is 2 hours. And then 13 to 14 is 3 hours. 14 to 15 is 4 hours. And then 15 to 16 is 5 hours.
Good. So a very common thing is to just count each number. Say 1, 2, 3, 4, 5, 6. That happens a lot. So you do have to make sure I'm actually counting the movements. From 11 to 12 is 1 step. From 12 to 13 is 1 step. So 100 miles in 5 hours. How fast is that?
We have to divide.
Yep. Because miles per hour is speed. You see your highway sign.
20.
Good. 20 miles per hour. Does that sound very fast?
No.
So it wasn't just that it was the highest piece. That didn't necessarily make it the fastest. We want to go the biggest distance in the shortest amount of time.
Right. So I would go with
So
0
you were
to
right.
6.
Yeah, the bottom one.
Okay, bottom one. Let's check. So the bottom one is 0. It starts at 0 and you end at 150. So how many miles did you travel?
150 miles there. That's
150 miles. And how many hours did that take?
1, 2. Well,
5 hours.
1 is 1 hour. 2.
So this one is a little confusing because they didn't mark 0. But you started here and not at the 1.
1. Then you got 2,
2, 3,
4,
5,
6 hours.
6 hours. So 150 divided by 6. Calculator.
That's going to be a messed up one.
Actually, it came out nice. Sometimes
Oh,
it
okay.
can come out weird, but
25, yeah.
25. So 25 miles per hour. Does that sound very fast?
No.
Still no. So it's not about the length of the line. This one looks long. We want our distance to be really big. If we look at this line here,
So AN, D is out of the equation.
A is out, D is out.
6
So
to
if we
8.
So 6 to 8, that's only 2 hours.
But how fast?
But how fast, we needed to know the distance. If we were at 150 miles and we ended at 325, this one's in between. How long of a distance is that?
100 miles.
100 miles would take you to 250. If you start at 150 and go 100, takes you to
Okay,
250.
200, 300, 300 miles and a half.
300 would take you to 450. If we start at 150, add 100, that takes us to 250. Add 100 more, that takes us to 350, which was a little too high. We only wanted to go to 325.
So it'd be 325.
Well, it'd be a little less than 200. The
So
easy. Sorry, go ahead.
So it'd be 250, somewhere around in there.
It'll be 275. The easiest way would be to take the big number minus the smaller number. Oh, I said 275. I meant 175. It's a little under 200. So 175. So 175 divided by 2, because it only took 2 hours to go that far.
2 into 8 is 16.
So it'll be about 80. If we want to find it exactly, we can plug it into the calculator. So 87.5.
Jesus Christ. My niece is screaming all loud. Shh.
It's hard to get kids to be quiet when we want them to.
Like,
So does that sound fast? 87.5?
Yeah, that sounds
That
fast.
sounds really fast. So on the graph, it didn't matter whether it was the top piece or the bottom piece. It mattered which one was the steepest. So on a graph, fast is steep lines. This line got tall fast. This piece just went up really quickly, whereas this piece, it kind of went up slowly.
And then the other ones just kept following along, but real slow.
Yep. The steeper your line, the faster you're going.
dang, that look different.
Yeah, all that riding.
It's nice when you can just erase it all at once.
Hey, which expression represents 270,000 written in scientific notation?
This is where the calculator comes into play.
You could, but they kind of are trying to trick you again.
B.
I think all of them actually make the number 270,000. If we typed all of these in, if we did 270 times 10, here you have to do AB. This button gives you the exponent, so times 10 to the third. That's 270,000. If we do 27 times 10 to the fourth, also 270,000.
Wow.
They're kind of trying to trick you. With scientific notation, it's not only about it coming out to the correct number, it has to be written in the right way. So when you're in scientific notation, the decimal should always be behind the first digit. We want 2, that's our first digit written of this whole number, then the decimal, 7, and then any extra zeros don't need to be written.
So it'd be C.
So it'd be C. There's only one that has the right format.
See, I was counting the zeros still. I thought, 1, 2, 3, 4 zeros.
Yes, but since
That's
they
not
want the decimal, yep, that's kind of why they wrote the problem this way, is because you can think about it a lot of ways. Some people are like, oh yeah, just count the zeros. But when they say scientific notation, they mean specifically that decimal should be right behind the first number. And if they did, so maybe instead of D being 0.27, maybe they say 2.7 times 10 to the 6. So if there are 2 that look the same with the decimal, this is where the calculator would be helpful. If we go type those 2 into a calculator, 2.7 times 10 to the 5th versus 2.7 times 10 to the 6th, those will give you 2 different numbers. They look pretty close, but you can see this one has 4 zeros instead of this one has 5. So yeah, scientific notation means something very specific. It's not, just write it in a random, it's not just this times 10. The decimal has to be in the right spot. Okay. I don't think we've seen one of these problems for a while. I'm not even sure we've talked about a problem like this in this.
Yeah, X and the Y. Yeah, we did.
So the table below shows the values for X and Y. Which of these equation represents the relationship between X and Y?
Yeah, we did a table like this a couple weeks ago.
Okay. Do you remember what we did to go through this table?
I don't.
We had to put the Y would be, the X would be first.
Mm-hmm.
So you'd have to just put an X. Well,
Okay. So you're kind of on the way there. We want to take an X.
yes, you want to put an X there.
And plug it in and see if we get the correct Y value.
Yes, and then you do the Y after that.
Yep, you're trying to figure out the Y. Now, 0 and 1 are usually bad ones to pick. If there's any other options, I'd pick the other options. Sometimes the 0 and 1, 2 of these will work for it. So I'm going to pick the 2 just to be a little safer.
Mm-hmm.
Oh, yeah. So when I plug 2 in here, I should get 3. That's the answer we want. These 2 go together. So if I plug in 2 for X, this becomes 2 minus 1. And what do we get when we simplify that?
It's not going to be 3.
Not going to be 3.
And 1.
Get 1. So then we try answer choice.
Oh, okay, we did do this.
Okay,
Yeah.
that's good. So now we try answer choice B and we do the same thing. Plug it in. Are we going to get 3?
No,
No.
Nope,
definitely not.
definitely not 3. So then we try the next one.
Minus 1. Nope.
Well, what's 2 squared? What does 2 squared tell you to do?
Oh,
Multiply.
2 times 2. So yeah.
So 4 minus 1 is 3. This
Yeah.
one does work.
Yep.
So with the Desmos calculator, there is actually a second option. I'm going to clear all this writing out. So on the Desmos calculator, you can add a table in. You can go to this plus sign and add a table in. And you can literally type in this table. 0, -1, 1, 0, 2, 3, 3 would be 8, 4, 15, and 5, 24. So you can see it's actually putting dots on your screen for that table. And then you can type in each answer. The first answer was y equals x minus 1. If you type it in, it does go through 2 of the dots. Does it go through every single one?
No.
Didn't work. So then you would go try the next one. X plus 19. Y equals, and I'm going to do it on this instead. Y equals x plus 19.
And that don't work either.
There. So we try again. We say y equals, the next one was x squared. This a squared button will get you the 2 minus 1. And now you see it goes through every single dot.
Make it nice and easy.
So that's how you get your answer?
Mm-hmm.
Wow.
Yep. This Desmos calculator is pretty nice, but it only really works for, problems like this. If they give you a table and they say which represents the relationship, this kind of question, you can use Desmos and type it in. But then you have to remember how to type it into Desmos. So it's a good and bad process because it's easier, but you have to remember how.
Yeah.
Okay, so another free response type question. Triangle DEF has vertices with coordinates -2, 1, 1, 5, and 2, 3. Draw and label triangle DEF on the grid provided. And then draw a new triangle by translating each vertex. Okay, there's a lot to this question. So we're going to take it one at a time. So we don't have a grid provided. I'm going to have to draw in a grid. With that, nope, that does not give me a grid. I was hoping to have like an automatic grid. Okay. I'll draw in a grid. So on a question like this, it can seem overwhelming. Instead of reading the whole question, most of the time I say read the whole thing. I'm going to take it one at a time, and I'm going to start with the draw and label triangle DEF. I'm going to ignore every other set of instructions and just do the first one. So if you have trouble graphing, if you're like, I'm not sure where these are supposed to go, the Desmos calculator can help again. Even if you don't have an entire table, you can type in a coordinate, -2, 1. Let me exit out of what we had. You can do parentheses, -2, 1. And it'll show exactly where the dot goes. If you've messed with the calculator, you can hit the home button, the default zoom, to make it back to normal. So now we know where the point should go. If you forgot, well, this is how I graph. Once you know the location, left 2, up 1, you can graph it yourself. So left 2, up 1, that's our dot. And then what letter would I put by that dot? Tells me a letter.
D.
D.
The letter D. So then E is 1, 5. If you forget again, I don't know how to plug this into Desmos. To remember, you can always say, okay, the first letter or number, the first number tells me to go left or right. If it's +1, I'm going to go right 1. The second number tells you to go up or down. Since it's positive, it'll tell you to go up 5. So these are instructions of what order do I do stuff in. From the center, I go up, or sorry, keep saying the wrong word. From the center, go right 1, up 5. Or if you remember how to use Desmos, you can type it into Desmos, get the location, and then graph it. So D, E, and then we have F is 2. So right 2, up 3.
Yep. They're really close together.
They are pretty close together. And most likely you're going to have an actual grid, which is easier to do. It's hard for me to draw in a grid. So probably it will be easier to find the locations of where these points go. So even if that's all you can do, do it, because that still gives you points for the question. Better to get some, even if, okay, now we read the second part and we're like, I'm not sure what to do. This one is, there's a lot of writing. So draw the triangle D prime, E prime, F prime. These apostrophes in math, you say the word prime. It just means it's going to be a new triangle. So draw a new triangle by translating each vertex of the triangle, DEF, 3 units to the right and 2 units down. Appropriately label triangle D, E, D prime, E prime, F prime.
So you gotta move it.
Yes, translating means slide it around. So specifically 3 units right and 2 down. So it's really just about keeping count. 2 things to watch out for. We saw this when we were looking at the other graph. If you haven't moved yet, you don't count yet. I don't count where I started as 1. I count over 1, 2, 3. The second thing to watch out for is this line, the up and down vertical line. That counts as a space. I don't go 1 and then skip over 2, 3. I do 1 on the axis line itself, then 3. Oh, that's not the point yet though, because from there we go down.
There you go, down. So that's gonna be negative.
Yep, so now we're in the negative realm. So since we moved the letter D, this is going to be labeled D apostrophe. It's that D prime.
Okay. Then you gotta do that for E and F.
Yep, so now we go E. And again, it'll be easier on a grid if you have a grid system. Let's see. That's going to be too hard. I was thinking of maybe drawing it on Desmos, but that's going to be too hard. We'll just keep with this. So right 3, down 2. And then the F, you're going to go right 3, down 2.
Oops.
Sounds like they're playing a little too hard there.
Yeah.
Mine are upstairs yelling.
Like, I didn't know you heard that. I'm looking at them like, are you crazy?
All I heard was my nuts.
Oh my God. They fat.
That's just normal kid stuff, kids. Are loud. Okay, so we've done the second one. We don't need to worry about that anymore. We did it. So now, draw the triangle D prime or D double prime, E double prime. It just means
Oh wow.
we're moving it again. One more. Now it's a new triangle.
Don't they understand that this could be very confusing?
They do. They do. That's kind of why they did it.
Wow.
By translating each vertex of triangle D prime, E prime, F prime. Usually when they do a problem like this, it's never going to go back to the original. We're never going back to the black triangle. Now we're going to take the red triangle and do something to that triangle. So this time it says 2 units left and 7 units up. Appropriate label, the triangle. So 2 units left, 1, 2 spaces, 7 units up. 1, 2, 3, 4, 5, 6, 7. I didn't even draw tick marks in for these. And they'll give you a grid that's big enough. And then, oh, no, D double prime. When you label it, we use the new 2 apostrophes. Then we go 2 left here and up 7, 2, 5, 6, 7, double prime. We do the same thing for F. We go 2 left, 1, 5, 6, 7. And since it's a triangle, we connect the dots.
And the negative always stays on the bottom, right, of the grid on the other side?
Not necessarily. Like you saw, D originally was negative in the left direction, but then it went positive when it got to D prime. Maybe I misunderstood your question.
I mean, on the other side, because you always have positive on one side, negative on the other.
The grid itself, yes. The right side is always positive. The left side is always negative. Or the upside is always positive. The downside is always negative.
Okay.
Yeah, that will never change. Okay. So then the last question. Describe the movements necessary to perform a single translation of each vertex from triangle DEF to triangle D double prime, E double prime, F double prime. That's saying if you did start at the black, this triangle is black, and you ended at the green, how would you do that? So if you start at the black, how far right do you have to go to be directly under the green D double prime?
1, 2, 1.
Just one space. So the translation, the movement is you go right 1. And then how many spaces up do you have to move to actually get to D double prime?
3, 4, 5, 6. 6.
I think it's only 5, but I don't think that's
I
your
was counting
counting.
from the middle.
It's really hard where it's not a grid. They'll give you a grid where they have the
okay.
actual lines. You know, if you had all the lines going around.
Oh, so you just count from where the dot was at and count up.
Yep. Yep.
Vertex. Okay. I was counting the middle on accident.
Yeah, no, we want from the dot itself and not from the center right now because they want the movement from the black triangle to the green, not from the center to the green.
Then it would be 5.
Yep, so right 1, up 5. So a question like this is pretty long. If this were me and I was taking this test, I would skip this one and come back to it last. It's one it's super long. There's a lot of steps. I'm going to try and get all the points and use my better brain power for problems I'm sure I'm going to be doing fairly well and leave a problem like this, but always come back and try it. You get
I was thinking the same thing, like this will get skipped.
Yep. Still try and at least do something. The more you try, the more points possible. I wouldn't leave it completely blank, but I definitely would save it for the end because it is a tough question. There's a lot going on in this.
And it's going to take a little more time than the other ones will.
Mm-hmm.
Yeah.
So this one says, which number is irrational? Do you guys know what it means when they say the word irrational?
That is improper. Is it something like improper?
Improper, like I can see how you're relating the two, but improper is a very specific math term. It's weird because like you have to learn a whole new math language. So an improper fraction means like problem D is an improper fraction because it's a big number over a smaller number. Okay. And so they sound, because in the English language, I would say like if we were just speaking English, yeah, they sound like very similar words. They have kind of similar meanings. But in math language, they actually mean two very different things.
Okay, irrational. Wouldn't it be like a single number with no negative, no square root, or no fraction?
Um,
I know.
I'm trying to think of what that would define. That sounds more like a whole number.
Yeah, that's what I was going to say.
Yeah,
That's
it's a whole number.
So irrational, again, it's a very specific, just math meaning. It's a number that can be written as a decimal that doesn't repeat but goes forever.
Oh,
No.
okay.
That's a whole number.
Move, Jamar. Gosh.
Goes forever with no repetition. So on a problem like this where they want to have you define a number, it can be helped to change them into decimals. It goes forever with no repetition. No repeats. So it's definitely not A or C. Those are not decimals at all.
No.
But let's check out B and D and see what they are when they are written as decimals. So square root of 8 in your calculator. The square root looks like a check mark button. On Desmos, it's located right here by the ABC. The square root of 8, super long decimal. Do you see any repetition, like, you know, does it go 82, 82, any repeats over and over again? No?
No.
So every calculator just stops at some point because it can't keep writing numbers. But that's literally because it can't keep writing numbers. Technically, you could keep writing this number forever. There's technically more digits than they have written. Let's see, the other one was 22 over 8. And this one definitely just stops. If it's a short decimal, it stops. There's nothing else. If it takes pretty much the whole space, it probably keeps going. You could also have a decimal like this. This one repeats.
Yeah, it repeats.
It looks like this 7 changes that pattern, but that's just because they rounded. Again, the decimal is like, well, I have no more room to show any more numbers. So since the 6 would round the number next to it up to a 7, it just rounded. If most of it's repeating, then really this is 0.6666666 forever. It just can't write that out. So this is irrational, the square root of 8. This is called rational when the decimal just stops. And this one where there's the repetition is actually also rational. So these two would be rational. This one is irrational. So B is our answer.
So is the square roots always irrational?
That is a very good question. Almost always, but math can be tricky. This is why you should always type it into a calculator. What if I said square root of 9?
Just 3.
Just 3. Square root of 9 is actually, so 3 actually has a couple of categories. It can be called an integer, could be called rational, could be called whole, could be called an integer. It belongs in a lot of categories. Definitely not irrational though. So that's why I always type it in, because you can have so many different square roots where maybe one doesn't work, but the next one will. Like, so you've just got to be careful with that.
Oh, okay.
So I think we have time for one more question, and then we'll end for today. Julie does not want to spend more than $300 on ice skating. Her skates will cost $42. Her lessons will cost a total of $56. And the practice time will cost $7.50 per hour. Which inequality should Julie use to determine the maximum number of hours she can practice without spending more than $300?
Well, you would need to add the 42, the 56, and the 7. Well, yeah, the 42 and the 56, the practice time, and
Yep.
750.
So if you're trying to find total cost, you add stuff together. But the 750 is slightly different because it wasn't just 750, it was 750 per hour.
Yeah, so you got to go times.
So you got to go times a letter. And they're probably going to use H for hours. So even if we don't know exactly what the more than means, there's only one expression that matches this. I have to add it all together. What's our answer?
It would be D. That's the
So-
only one that makes sense.
That's the only one that makes sense. So the more than, just to talk about it though, if you don't want to spend more than an amount, that means you want to spend either exactly that amount. I could spend exactly $300 and I'm okay because I didn't spend more than 300. Or I want to spend less. You know, if I can get it for 200, why would I want to spend 300? So the word more than actually means less than or equal to. It's kind of a weird word because you expect the word more to mean greater. But when it says the words more than, that actually means less than or equal to. So if you knew what the word more than meant, you could say, oh, it's not A or B, they have the wrong inequality symbol. So next week, I am going to be